Welcome everyone to another episode of our podcast. Welcome to AtomPRO Podcast. Today we're going to dive deep down into the quantum world, and some of you probably have seen that the new Nobel Prize winner, they also did some research about quantum physics. Now we're going to learn more what is quantum physics in the past, what is quantum physics doing right now, and what will be the futures of quantum physics. Today we join with quantum enthusiast, and he is working in Rosatom in quantum department. He will answer all of your questions and to answer all of your curiosity about this quantum world. I would like to introduce you to Mr. German Pachikov. And could you please introduce yourself a little bit more, and can you tell me why did you call yourself as a quantum enthusiast?
Yes, of course. Thank you very much. First of all, thank you for calling me here.
Yes.
I'm really happy to be here today and to discuss this fascinating topic. So, my name is German Palchikov, yes, and I work as an expert in educational department in Rosatom Quantum Technologies. My job is to develop some methodological things, and also its popularization of quantum physics, quantum technologies for students, like school students, university students, and for anyone who wants to know about it. So why a quantum enthusiast? First of all, I'm not quantum physicist. I'm not just even a regular physicist, but I am just fascinating. I really like physics, and I believe, why I'm enthusiast, I believe that in the nearest future, maybe 10, 20 years, quantum physics, quantum technologies will change the world. I mean, it will change everything. All the technologies we have today will change many things.
Yeah, exactly.
And we will discuss it later.
Yeah.
So that's why I am enthusiast.
Yeah, but first I'd like to know, how did you find out about quantum physics?
How I found out?
Yeah.
I think everything began with curiosity, like it happens. When I was a child, I think about 20 years old, or maybe 10 years old, No, 9 years old, yes.
9 years old.
I remember.
So you're young age.
Yes, I found out some kind of book. It was just like simple physics experiments. And there was such an experiment, a very simple one. You had to take a magnet, a piece of paper, and some metal pieces, small metal pieces. You should just put this magnet. Above it, you should put a piece of paper, and then these metal pieces. And actually, I was so shocked. I've seen not just moving metal pieces. I've seen something like magic. I understood that our world is ruled by some hidden rules that we are not able to see, but sometimes we can find them. Yeah.
Exactly.
So that was the beginning. Then I started, I think physics was my favorite subject when I was at school. And when I was in university, I found out that there is quantum physics and a quantum world, and it changed everything because it was like magic to me. What is magic, by the way? Magic is something that we are not able to understand. We are not able we don't have such experience. I mean, we have our life experience, and magic, it's something that changes experience. It's something completely different. And quantum world, it's something completely different.
Yeah, exactly.
It has another just mind-blowing rules that we are not able to understand sometimes because we don't have such life experience. That's how it began.
Yeah.
And now I'm a very lucky person because I can work with quantum physicists. Sometimes I can ask questions, we can discuss something, and I can also look at them with shiny eyes full of love. Yeah,
That's
quantum physics
yeah.
is amazing.
That is such an interesting journey of yours. You really love physics at such a very young age, and physics is not for everyone. I would say that because some people they really hate physics.
Show me these people.
Some they thought that physics is really hard, but for you, you're different. You interest in physics, and now you also interest in quantum physics. And for me personally, I've learned about quantum physics when I watch movie in pop
Yes,
cultures.
of course.
Yes, they mention a lot about quantum, but I have no idea what is quantum's world.
Great, great. Actually, I'm really happy that you
Yes.
just mentioned movies,
Yes.
because I wanted to ask a question. What do you know about quantum physics?
Yes.
And I was expecting that you will tell me that you know something about quantum physics from movies. Yes. By the way, do you remember any movies and how usually we use quantum physics, quantum technologies in movies?
Well, for now, I could name two.
Yep.
One is Avenger Endgame.
Yep.
Second one, I would say Ant-Man and the Wasp.
Great. And they're connected, actually.
Yes, they connected because they used the quantum technology to do time traveling and to travel into the quantum realm, like the small world.
Yeah. As far as I remember, in the Ant-Man, he had technology that with what he could just shrink and get into the quantum world.
Exactly.
I mean, a very, very tiny one.
Tiny
particle. And in the Avengers,
yes,
they took this technology and made time traveling machine.
Exactly.
And just try to remember how many minutes have they spent just to build this machine. Just imagine time traveling. It's something mind-blowing.
Exactly.
But how many minutes from the plot they've spent to build this machine?
I think like 3 to 5 minutes.
3 to 5 minutes, yes, actually. And they've told us, okay, we built the time traveling machine, and we have question, how? And they've told us what? Quantum technology.
Yes, exactly. Quantum
and actually, that's enough for us.
Yes, but we don't know much. Like, what is quantum technology? Like, where is it from? Where was it? So I think, can we go back a little bit? What is like quantum physics?
Quantum physics. But what is quantum?
Quantum, I think, is a particle, like small.
Yes,
particle.
It's a particle. Yes, it's a very small, tiny particle.
Yes.
Very, very small.
Yeah.
Or portion of energy. So we have quantum and we have quantum mechanics. Quantum mechanics learns how these particles behave, and quantum physics learns about these particles. That's it. So let's come back to the topic of movies. Actually, if we will try to find out how many movies for the last 10 years have topic like quantum physics or quantum technologies, we'll find more than, just use IMDb or Kinopoisk, we'll find more than 50 movies, yes. So from the one hand, it means quantum physics is very popular. Yes. Because we can see it in pop culture, not only movies. Do you remember any other, I don't know, things where we can, I mean, pop culture things where we can find quantum physics?
I don't quite recall that. Could you tell me more about it?
Yeah, of course. For example, I don't know, comics.
Comics, yeah.
Yes.
Yes.
But not only comics, cartoons, maybe in music and songs.
Probably, yes.
Probably. But I don't know.
There's probably a music video of the Hollywood and pop song. Yeah.
Sometimes I think we can find something quantum. And of course, books. Books, I mean fiction books. Science fiction, etc. So that's quite a very interesting thing. From the one hand, quantum physics is very popular, and quantum technologies, the things that we are discussing today. But from the other hand, we can just see how usually people use quantum physics in pop culture. it's something about technologies that we don't have today,
Yes.
that actually is more magic than a science. Why do you think it's so?
Because I think some sort of like time traveling and traveled into small particle, it sounds very unrealistic at this moment.
Yeah, just like magic sounds to
Yeah,
us.
they sound like magic, obviously.
For people who are not physicists, quantum physics is something that we think is very, very difficult. But today, I hope we will discuss three main technologies that we really have and that will change the world in the future. But let's discuss it later.
Yeah, so speaking of that, I like to know back to the past. Like,
Yep.
as I heard this, like first revolution and second revolution of quantum. Could you please tell us more about
Yeah,
it?
actually, that's quite an interesting thing
Yes.
because now we are in the second quantum revolution. Actually, the first quantum revolution is a very, very important thing for theoretical things. I mean, for theoretical physics, quantum physics, and for quantum technologies, because the first quantum revolution was mostly in the 20th century. So actually, people made some discoveries and made the fundamental discoveries for quantum physics that we can use today. And also, we have few very important technologies from the first quantum revolution. For example, have you ever used, I don't know, laser point, you know?
Yes.
And this is absolutely a quantum technology that we use every day. For example, I don't, in our smartwatch, they can count our pulse using laser and many other things, like, I don't know, CD disk. CD disk, we can just drive data there using laser, of course. So the first quantum revolution was about some fundamental discoveries and theory, and also some technologies that usually use trillions of these particles, I mean quantum particles. For example, laser use what kind of particle?
Beam? Is it?
Laser beam, yep.
Yeah,
What?
beam particle.
No, it's particle of light. Photon.
Photon,
Yes, of course, photons.
photon.
So trillions and trillions of photons.
Yes.
And yes, actually we can say that the first quantum revolution is about using trillions and trillions of these particles. How we can use them, how they behave. It's called collective quantum effects. Why collective? Collective because we use trillions of these particles. Or some other technologies, I don't know, flash drive. Actually, your mobile phone, it's quite a quantum technology. So the first quantum revolution was about, first of all, this theoretical part and these discoveries, and the second thing is about some collective quantum effects and using of them in technologies.
Yes, that's really interesting. And you mentioned a lot about some of the technology that we have been using in our daily life, but without knowing that it's related to quantum physics or quantum mechanics. And could you please tell us more some of the things that we might be using and we might not know that it relates to these kind of technology?
Yeah, of course. I've already mentioned lasers.
Yes.
Some parts, components from our devices. For example, flash drive, as I've told you. Some things like medical equipment. The kind of things that catch the magnetic field, and actually much more, because with laser we have a lot of technologies. I mean, like CD disc, Blu-ray discs, like counting pulse, and many others. So these technologies.
But one thing, how about quantum computers?
It's the second quantum revolution, yes. So that's not about the first one.
So could you please tell us how did they find out about quantum
Nowadays,
revolution?
we live in the second quantum revolution. So look, the first quantum revolution is about collective quantum effects. The second quantum revolution is about single particles. Yes. It's about how we learned to use not the crowds of these particles, not the trillions, but we learned how to catch, just make to stay, and use these small particles and make some technologies using just individual, it's called individual quantum effects. And of course, you've told already about quantum computers.
Yes.
And actually we have three main technologies from the second quantum revolution. It's quantum computing and quantum computers. It is quantum communication.
Quantum communication.
Yeah.
Can you please tell us a little bit more about it?
Yes, just a second. And the third one, it's quantum sensors.
Quantum sensors.
Yes. So what would you like to know about?
So you mentioned three parts of the quantum technology that we are doing currently. Quantum computer, quantum communications, and quantum sensor. Could you please tell me the last two? Because these two I'm not really familiar with. Could you please tell us a little bit more?
You mean the quantum communication and quantum sensors?
Sensor. Yes, exactly.
Actually, yes, I will tell about these two parts and technologies, and then I will tell you more about quantum computing, because that's the thing we are doing in Rosatom Quantum Technologies.
Yes.
So, as we discussed, there are three main technologies today.
Yes.
Quantum communication. Quantum communication is about building some very secured lines for communication, and we can use there a particle of light, a photon. Just imagine if a hacker tries to, I mean, that's a big problem in modern world. Today our data, I think it's stolen every day.
Yeah, cyber attack.
Have you ever lost any data? I mean, your phone number from that databases, your surname, your address.
Kind of like sometimes random people called me to sell some services.
That's a good thing. But sometimes some really bad guys calls you and tries to steal your money. Scam you.
Exactly.
That's the thing why it happens, because we lose data. We use our phone numbers, we use our, I don't know, our emails, I mean our password sometimes. And that's a very big problem today, because we live in a world of data. Data is everything today. So quantum communication is about using and building very secured lines for communication, using the laws of the quantum world. So it's not about encryption. It's not about any codes that will protect your data. It's about the laws of physics that actually protects your data.
Wow.
Yes, because we can just make such a communication line, use single photons. And if a hacker, for example, a hacker, for example, tries to steal it, it will disturb the state of this photon, and you will definitely know that the information, the data was corrupted, that the data was stolen. So that's all about it. That's what about quantum communication. But what about quantum sensors? That's a very, interesting thing also. First of all, we can build such sensors that are very sensitive. Extremely sensitive. And for example, they can sense something like, magnetic field. We can use it in many things, prediction of earthquakes, finding some minerals, etc. And the second thing is we can make the sensors very small. We can use just particles, these quantum particles. And they're so tiny, we can put them inside, a living cell in a human and just see what happens there. That's about quantum sense. And my favorite thing my favorite topic. It's quantum computing. Yes.
Yeah.
Have you heard about it?
Well, I've seen some video on internet before, but they.
Do you know such a series? It's called Black Mirror.
Yes, I love that one.
Have you watched the last season?
Yeah, it's about the chips into people's brain, about those kind of things.
Many things. Actually,
Yeah.
there was the second, I think, series was about quantum computer.
Yeah.
Don't you remember what it did?
I quite don't recall, but if you like tickle it a little bit, I could recall that part.
I can tickle you a little bit. No,
Yeah.
sorry. So actually, quantum computer in the last season of Black Mirror could do anything. I mean, if you off the quantum computer, you could say it, change my, I don't know, my pants from black into red. Just move me or teleport me to China.
Yeah.
Make somebody speak not his native language, but I don't know, Deutsch, German. And anything. How do our regular computers work?
It's used the bit 1 and 0.
Oh,
yes.
Yeah, you know this thing.
Yes.
Yeah, actually, the main thing about our regular computers, it's transistors. Transistors, it's a very tiny component that usually there are just billions of transistors in, how do you say, in processor?
Yes. Like...
and it's like a tiny switcher. So it has actually, yes, as you told me, it has two positions, 0 and 1. So actually, what do we have in our regular computers? We have these tiny components called transistors.
Yes.
You know what they can do?
They can translate the computer language into the real thing.
They're like tiny switchers. Yes, they have two positions, 0 and 1. And that's how we can realize and make this cell of information in computer called
bits.
Bits, yep.
Yeah.
Bits. Using these zeros and ones in bits, computer can make computing. I mean, all information in our computers is just coded in these zeros and ones. So more bits we have, more information we can have, we can change, we can do. But what is quantum computer? What's the difference?
I think in quantum computer, they use more than ones and zero.
Sometimes, yes.
Yeah.
But actually, if we will talk about zeros and ones, how do they work? If in our regular computers, even in supercomputers that can, I don't know, just all the building can be the computer. Even in this kind of computers, our information can be only, and our bytes can be only in two positions, 0 and 1.
Yes.
But for quantum computers, we have not a regular bytes, but quantum bytes called qubit.
Yeah.
Qubit, yeah. Qubit. And what's special about these qubits? Our qubits can be actually just simultaneously in a few positions between 0 and 1. They can be simultaneously 0 and 1. Actually, we have a few mind-blowing rules in quantum physics. One of them called quantum superposition. And it says that our particle can be in a few states simultaneously at the moment. That's why if we will take this part and make these parts work for us, we can use superposition for our computing. But what it gives us? Any ideas?
Like a strong encryption than the
normal
computer?
No. It's not about strong encryption. It's about explore massive number of possibilities, actually. Because, for example, just imagine if you are, I don't know, lost in a labyrinth. How could you find the exit?
We'll try to find the way out.
Yeah, for example, I don't know, you will use the rule of left hand.
Yes.
You will go the first way from your left hand, you will, I don't know, just find there is no way out, came back, and then you will go the second, the third, etc., until you will find your way. Your way out, I mean, your exit. What will do our regular, even some supercomputer? How can it find out?
I'm not quite sure about that. Can you please tell me more?
That's quite an interesting thing. It will do the same thing as you. I mean, it will just
like as human brain,
as we do. I mean, it will just make a few operations for each way. It will try. I mean, it will code it in 0 and 1s. And then it will try the first way, one operation, the next one, the next one, the next one, until it will find. But what will do our quantum computer?
They probably can find a way to skip without like...
They can skip, I mean, all these things. And it will go simultaneously all the ways. It will be one operation. So it can code all these ways, I mean, zeros and y's, for one operation. That's the thing. So actually, that's the best thing, the best, I don't know, example that I can give you. Quantum computer can explore a massive number of possibilities at the same moment, I mean, simultaneously. So that's the thing. And how do they use? How do they work, actually? They work with two main rules. The first one we've discussed. What was it?
Superposition. Oh, okay. First one. Superposition.
Superposition. Yes. So it means that the particle can be in a few states at the moment. That's how we take these parts, make qubits with special operations, and then we can use them. So they can just be not only 0 and 1s, but both when the operation goes. But the second thing, we cannot use only one qubit. I mean, we cannot make any operations with one qubit. We need more. We need 10, 20, I don't know, hundreds, thousands of qubits. So that's the second rule, very important. The first one was superposition. The second called quantum entanglement. Quantum entanglement, it's a rule from quantum physics. And it says that if particles, two or more, entangled in special way in quantum world, they are connected.
They are connected.
Independent from the distance between them. If you will change the state of one of them, simultaneously the second one or more will change.
As well. Wow.
So we can take our particles, make qubits from them, and they will use superposition for computing, and also we can entangle them. So we can use more than two qubits. We can use a lot of qubits at the same world. And that's how our quantum computers become more powerful.
Wow. That sounds really interesting. You mentioned about the quantum computer, and you also mentioned about quantum communication, which really caught my attention because typically the cybersecurity, they usually use code to avoid from hackers or cyber attack. But with this quantum world, they used physics instead and sensors as well. I think it will be more such an advanced technology for minings and stuff like that in the future. And I would like to go back a little bit too.
I just want to add something.
Yes, sure.
You've talked about codes and encryption, and actually quantum computers are codes very dangerous thing for our just modern encryption. Because our regular computers, even supercomputers, it's really hard for them just to hack these codes for encryption. But quantum computers, when they will be enough powerful, they will do it really easy.
Whoa.
So that's why we have also quantum communication, very important for us today.
Speaking of quantum computer, you also mentioned earlier that it is something that Rosatom currently doing.
Rosatom, yes, actually, Rosatom is one of the, I think I'm not afraid to say, world's leaders, yes, in making quantum computers. Because nowadays we have this roadmap for quantum computing that Rosatom is responsible for from our, government. And quantum computers it's a thing that we are quite strong in. But nowadays we have a very respectful position in the world, because first of all we have quantum computers. We have all 4 platforms for our computers, the most popular. The ions, the neutral atoms, the superconductors, and photons. We have quantum computers on each of them. And we also have very powerful quantum computers with 50 qubits. Yes. So that means we are one of the leaders in the world with quantum computing.
So it sounds like this is an advanced technology, but will this technology will change the size of the computer? Will it's going to be big, or will be like a normal size
That's a good question. Let me think. I think I can a little bit transform your question. First of all, will our regular computers go away if we will have enough of and powerful quantum computers? The answer is no, because quantum computers are very useful for some specific things, really specific things. They are not really useful for, I don't know, gaming.
Like office.
For what?
Office, like
for Microsoft typing, Office, for I don't know, internet surfing or something like this. They are not really useful. And also they're massive. Today they are massive because the quantum computer, they do not look like a regular computer, like your laptop. They look like just a big device with many components, with some specific conditions. I don't know, for example, very low temperature sometimes, vacuum, I don't know, etc. So they will not change our computer. They will not just move our computers. They will be. We will have them, but for specific tasks. Yes. I think actually we can. If you will need some, I don't know, to do some specific task, you can use a cloud platform in the future. This quantum cloud platform, you can send data, and it can give you answers. But you will not have quantum computer at home. You will have your regular laptop.
Yes, I see. So we mentioned a lot about what we are doing right now with quantum technology in current state. I'd like to hear your perspective about in the near future of this technology. What is your vision about this technology in the next 25 years or 30 years?
I like this question. I think it will change everything, actually. It will change the world. And there are a few ways it can go, actually. First of all, let's imagine that somebody, that not very good guy, some badasses will get quantum computers, and they can hack everything. All our data will be hacked. That's it. But also, quantum computers are very good at many things, at many specific tasks that our regular computers today are doing very slow. For example, in medicine, looking for or searching new drugs, new medicine, and new molecules in biology. It's a task just for explore massive number of possibilities. And that's why it's so hard for our regular computers. I mean, our even supercomputer for, I don't know, for searching molecule with some specific purposes, yes, purposes or conditions, can spend 10, 100,000, even more years. Yes, but quantum computers, remember the example with labyrinths, will spend, I don't know, hours or days for these tasks. So we can find new medicine, new drugs. If we will have, I don't know, another COVID, we can find medicine against this virus much more faster. Also, we can find some new materials. That's a very important task. There are a lot of things we are not able to do today because we don't have special material for this purpose. For example, superconductors. We need to find superconductors that can work not only with very low temperatures, but with a, I don't know, room temperature. Yes, with a regular temperature.
Yes.
That also we can do. New materials, new, I don't know, buildings, new. Another example, logistics today, just imagine the flight of an airplane.
Yes.
How many different conditions you should think about when you plan this way? I mean, from point A to point B, yes, the flight.
It's like a lot of process from the check-in to those kind of things, like security,
just
with the
tons of processes.
Yes,
because actually we should know the weight of the passengers. We should know how many luggage, baggage, yes, they have. We should know, we should count the fuel. We should know the weather conditions. We should know the condition of the airplane. I mean, is it old?
The engine,
is it new? What about engines?
Yeah.
What is the weather? What are different ways if something will happen? And that's a very actually difficult task.
Yes.
Because we can count all these probabilities, but it's very difficult for our regular computers. Quantum computers will do these tasks. Also, I don't know, just imagine life of a big city, like, I don't know, Moscow or...
Yes. Probably Japan.
Or,
they have
what's your mother city?
Tokyo.
Or Tokyo, yeah.
Yes.
Just imagine, it's like a life...
It's like
animal, yes, life creature. And of course, a lot of cars, a lot of, I don't know, buses, a lot of ambulances.
Yes.
They move every second, and we need to count how should they move.
Yes.
So that you could get to work in time, so that a patient could get medicine, etc.
Yeah.
And this actually works not really good today, because do you use taxi?
Yes, I do.
Yep. So you know that we get in traffic jams.
Yes.
We are waiting for it. It late. I mean the taxi.
Yes,
that's because we don't have enough powerful quantum computers today. In the future, we can solve these problems. That's it.
It sounds like this technology will solve a lot of problems in the futures, but there are not many people who are pursuing the degree or study in this degree yet. What is your advice that you want to give to students who want to pursue this degree?
Yes. First of all, it's not that it's quantum technologies. It's not that something will just come. It's technologies that we are building today together. So we need a lot of participants in this process. Of course, we need scientists.
Yes.
Of course, we need, and not only quantum physicists, but also experts in biology, in math, in engineering. Yes, of course, because the engineers build these things. And also, we need managers.
Yeah.
We need popularizators. And also we need, of
Influencers.
course, something like managers,
Mhm.
influencers, and many other professions. Actually, we need everyone.
Yeah, exactly. I think even
So
government.
our quantum technologies, its future, and any profession can find, can take part in building this quantum future.
And so one last question to you. So you're from a Russian company, and I'd like to hear from you. What role that Russia can play in the future in this quantum technology?
Actually, we are already in
Leading
position, yes.
Yes.
So there is such thing called quantum race. That's where all the world, all big companies like IBM, Google, Rosatom takes part. And somebody will win. Somebody will build a universal, powerful quantum computer. I think we can do it. Maybe, yes. So Russia and Rosatom can win this race maybe one day.
Yes. I think if this technology become like more advanced, it will be also such a big advantage to human in the future, because as you mentioned, it's involved in a lot of industry, even medicines. You mentioned like if COVID happened once again, it can fix the problem pretty fast.
Absolutely.
The increasing of population is also one of the biggest concern in current world, but with quantum it's also have like the way that people are moving more faster, even logistic with the airplanes also much more easier. The safety avoiding from scammer and encryption is also more advanced as well. It's such a really interesting technologies. So do you have any last word that you would like to say to our audience who are watching this?
Yes. First of all, again, thank you. I was really glad to discuss this fascinating for me, mind-blowing sometimes topic. Yes. The last thing I want to say, first of all, as I've told you, we all take part in this quantum future. So please become engineers, become quantum physicists, and come to our family, in Rosatom. And the second thing, it's normal when you don't understand something. Don't be afraid of it. It's just the point to start reading, start getting to know something new. So that's it. Thank you very much.
That is such a wonderful advice or last word that you give to our audience. And I would like to say thank you to you so much for joining with us today. It's such an honor for us that you share a lot about this world. I think it's such an eye-opening for me, because some of the technology I've never heard before, but you introduced me to it. And I also still remember you introduced me more about this back to early this year during opening text meter school. Yes, you deliver lecture about quantum as well. I think I still have the picture of you during that time. So once again, thank you so much for joining with us. And to our audience who are watching this, don't forget to check all of our podcast social media.
I have a few words. First of all, thank you for these wonderful words. The second thing, it's not, maybe I think all the information I've told you today, you can find it, read it, it will be even better. But as I've told you, I'm a quantum enthusiast. And I hope I could share part of my enthusiasm with you today. So guys, please learn about quantum physics. I don't know, watch good, read good articles, watch good podcasts, read my colleagues, for example, Dmitry Chemashentsev. He's a really good quantum physicist and a popularization influencer person. That's it. Thank you.
Yes, thank you so much. We need more enthusiasts like you in the future.
I hope we will have.
So if you guys have any suggestions or comments, feel free to leave it in the comment section, and we will try to improve it for our next episode of our podcast. Thank you guys so much.